The normal distribution, also known as the bell curve. We see it everywhere. But what exactly is it? How was it formulated? And why do we use it? These are the thoughts that Mortimer had. Perhaps you have thought them too. Mortimer took his questions to the local guru. What exactly is the normal distribution, the bell curve? The guru gave him a sheet of paper and a single die. The sheet of paper had the numbers 1 through 6 scrolled across the bottom. The guru told Mortimer to roll the die 500 times, each time placing an X above the number he rolled. And so Mortimer did. 500 times he rolled the die. 500 times he placed an X in a column, and 6 columns of X's rose like skyscrapers. Mortimer returned with his paper, showing 6 columns of almost the exact same height, which made sense, since one would expect the 6 possible rolls of the die to happen at about the same frequency. The guru then handed Mortimer another piece of paper and a second die. This time the sheet of paper had the numbers 2 through 12 scrolled across the bottom. He instructed Mortimer to roll both dice together 500 times, each time placing an X above the number showing the total of the 2 dice. And so Mortimer did. 500 times he rolled both dice. 500 times he added the 2 dice together and placed an X in the appropriate column. Mortimer did not realize this at the time, but what he was making on each paper was something called a histogram. A histogram is a series of columns showing the distribution of how frequently each of a set of possible outcomes takes place. The first histogram showed that each outcome from 1 to 6 took place at about the same frequency. But for Mortimer's second histogram, he noticed that the columns did not rise to the same level as before. The highest column was 7, indicating 7 as the most common total of the 2 dice. But to the left and the right of 7, the numbers sloped downward, making a kind of pyramid shape, with the least frequent outcomes being 2 and 12. Mortimer proudly returned with his second histogram. The guru then handed Mortimer 3 additional sheets of paper and 3 additional dice. He told Mortimer that he should repeat the same process, adding 3 dice, then 4 dice, and then 5 dice. Mortimer gladly accepted the challenge, and as he rolled dice into the night and added many numbers, he noticed that his histograms began to show distributions of a different shape. They were not flat like the first distribution. The histogram for 3 dice had a peak like the second distribution, but it did not fall off in a straight line. This time it was curvy, like a bell. The histogram for 4 dice looked even more bell-shaped, and the one for 5 dice more bell-shaped still. The next morning, a bleary-eyed Mortimer returned to the guru, proudly displaying his work. The guru then told Mortimer about a mathematician named Abraham de Moivre, who in the early 1700s had discovered the same thing Mortimer had just found. In particular, he found that for a large number of items added together, the distribution would get closer and closer to a certain bell-shaped curve. This fact would eventually be called the central limit theorem, and the bell-shaped curve would eventually be called the normal distribution, also called the Gaussian distribution, named after Carl Friedrich Gauss, another great mathematician. The central limit theorem basically states that when a large number of equally weighted random numbers are added or subtracted together, the result will be what we call the normal distribution. What does this mean for the world around us? Well, consider this distribution of test scores. We could make the case that for a given student, the performance on a test could be understood as the sum of a large number of factors that all would contribute to how well she did. When testing a large number of students, we see all of these competing factors adding together across their full range. The result is a normal distribution. Or consider this distribution of changes in stock prices. For a given stock, the change in price may be understood as the sum of a large number of competing factors. When considering the full distribution of stocks, we see that the result again looks a lot like a normal distribution. Our world is a complex one, but the central limit theorem teaches us that sometimes when we step back far enough, even in complexity, we can find simplicity. A distribution that shows that chaos can oftentimes be encased in a larger order. And as Mortimer found, this truth can be found with a single sheet of paper and some dice.